You want to double check?
No, I'm good. I don't. Okay, so we've talked about similar figures before. What we're doing today is finding the area of similar figures. So remember, similar figures are when you have an image that is just a bigger or smaller version of the pre-image. So the similar figures are the same shape, they've just been stretched out or shrunk down, they've been dilated somehow. So that's all a similar figure is. So we are going to go through, and what we're going to do today is we're going to get the area of like this one and say, if this area is 12, we're going to figure out the area of the image.
Wouldn't it be 24?
Times 2?
No. Well, it depends on how much is changed by.
No, that look like that's not
You
much.
can't find it out right now because we need more information. So I'm just giving you an example. If this area is 12, we're going to find out this one. So there is, we can find areas by setting up, I'll go back, by setting up a ratio.
Whoa. Similar figure to the image.
Oh, sorry.
Just a bigger and smaller version of the pre-image.
I also did this. Would you be scared to drive in NASCAR?
Oh my god.
We're doing a lesson.
Like when?
Okay. So we can set up a ratio of two similar figures to find both area and perimeter. I forgot we're finding perimeter today. So if you know two sides and the ratio is A over B, then they will equal the ratio of perimeters or the ratio of the areas squared. Ryan, close it.
Gosh, what is
It is
this?
closed.
Well, then don't switch over
I'm
tabs.
just leaving it.
Putting numbers and words into.
Okay, so if I'm going to look at these two trapezoids right here, and I know the ratio of little to big is 6 over 9, the ratio of the perimeters is also going to be 6 over 9.
What?
So, okay, so,
I know what you
I
mean.
think I might have accidentally deleted something on here.
Probably.
Yes, it's rational. Alright, so if I know that this ratio is 6 over 9, I know that the ratio of the perimeters also has to be 6 over 9. And if I know the ratio of these are 6 over 9, the ratio of the areas has to be in a 6 squared over 9 squared. So they've got to keep in the same ratio, except when we look at areas, we got to square whatever we have. So they've got to keep in the same ratio. So, if we're going to look at these same shapes, I'm going to find the perimeter and area that's missing from each one. So in these shapes, if I know that the perimeter of the smaller shape is 26, I can find the perimeter of the bigger shape by setting up a proportion.
Oh, that's
So it's got to be a 6 over 9, because that's the ratio of my shapes. And because I went from small to big when I wrote this first ratio, I've got to keep it that way. So the 6 over 9 is going to equal the perimeter of the smaller over the perimeter of the bigger. If the perimeter of the smaller is 26, and I don't know what the perimeter of the bigger is, I'm just going to go like this. And I've set up a proportion that we can solve by using our fish method, or we can cross multiply. It doesn't really matter either way. So I can find the area of this bigger trapezoid here without actually doing really any work. So I'm going to use my fish method like this. I'm going to go 26 times 9 divided by 6 equals x. And we can find Desmos, or we can plug that into Desmos and see what we get.
Let's find Desmos, guys.
So 26 times 9 divided by 6. And we get that the perimeter of the bigger shape is 39. I was going to say I just forgot it, even though I was staring right at it. It's going to equal 39. So the perimeter of the big shape is 39, but because it's perimeter, I better go in per meters because that's my units over here.
But you didn't put M on the 6 or the 9 or the 26.
Yeah, just my final answer needs it. Like I could put it here, go meters, 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 but since I'm just doing the work right here, I don't need it. But my final answer needs it.
Okay. Do you have to put square?
No, because it's perimeter. Area needs squared, so we're actually going to do that next. So I know that the area of the larger shape is 150, so I can find the area of the smaller shape now. So I'm going to go 6 over 9 is going to equal the area of the larger shape, or excuse me, area of the smaller shape over the area of the larger shape. So I know that if the area of the larger shape is 150, I'm going to find the area of the smaller shape, it's going to look like this. But we have one other thing. So, you know how we talked about the area of the, when I look at areas, it's squared and squared, right?
Yeah.
Yeah.
So I got to go through and do squared and squared, like this.
And the 152?
No, just these two. Just those.
Well, that's an area.
Yeah. But it's already been squared to find the area.
Oh.
So when I set this up, I can still solve it with my fish method. So 150 times 6 squared divided by 9 squared is going to equal x.
6, 6, 6, 6, 6, 6, 6, 6, 6.
So let me go over here to decimal. 150 times 6 squared divided by 9 squared. And it's going to equal 66.6 repeating.
Yes.
And when you plug it into decimals, keep the squares just like this. You don't need to do anything special.
Yeah, but I was calling it. I was like 6, 6, 6.
So it's going to equal 66.6 repeating. And I'm going to put my units, meters squared.
Nice. 6, 6, 6, 6. Perfect number. Look at me. Just kidding. Oh. My lucky number. Just kidding.
Alright, so we're just going to practice this today. This is pretty much all we're doing. So, if I'm going to look at these, the area of the smaller rectangular pentagon is about 27.5 centimeters squared. What is the best approximation for the area of the larger pentagon? So,
for the area now?
we're going to set up a proportion, and we're finding areas, right? So, I'm going to go small over big. It doesn't matter the order you go in as long as they're consistent. So, I like doing small over big personally. But so, small over big is going to equal, let's see,
We're looking for areas.
small is 27.5
over X.
over big, which I'm just going to call x. But these are areas, right?
So the 4 would be squared and
Yeah,
10 would be
so we
squared?
got to do the
Okay.
squares like this.
I'm so
So when it's perimeter, you don't need squares, but when it's area, you need your squares.
Oh, I see.
And then we're just going to set up, we're just going to do our proportion here. So 27.5 times 10 squared divided by 4 squared equals x. Plug it straight into decimals.
171.875.
27.5
It's
times divided by,
171.875.
what is it, 4 squared?
Don't listen to me.
171.875. 171.875 and centimeters squared because it's an area. So remember, if it's area, it's always squared. That's why we got these squares here. It's area.
Hey, you're square.
All right, not too bad. Hopefully.
Whoa, 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 whoa. That is pretty bad. 171.875. Okay.
All right, your guys' turn. So, scale factor of the two similar parallelograms is 3 over 4.
Oh, yeah.
The area of the larger parallelogram is 96. What's the area of the smaller? When it says up here, if the scale factor of the two similar parallelograms is 3 over 4, all that means is this small one is 3 and the big one is 4, like that. So, on your own, I want you to find the area of the smaller parallelogram. So set up your proportion. No, I'm not sure what happened. Why you're actually not on there. I don't think I printed for some reason. Do I still have the one?
Like this?
Yeah, we don't have like.
Yeah, I don't know why those didn't print. So we'll do like probably in.
Now just wait for Squad to be on.
Can I set this up right? And since it's perimeter, it doesn't.
Wait.
We're talking about areas, yeah.
Like that, since it's for the smaller one.
Yeah, but be careful. You did small over big, right? And that 96 is the larger one, so you better flip around.
Crap, I should put it.
Remember, when you set up your proportion, be consistent. If you start with small over big on the first one, you better do small over big on the second one.
No.
Because the area for the smaller one is 96, so we just square root 96. You advance that.
know?
Maybe about 30 seconds, then we'll go over it.
Oh, there won't be a square on that. 96, there won't be a square. There's only will be square on the 3 and the 4.
Minus 9 is negative 7, yep, negative 3.
Typo. Oh, is that on purpose, Goki? Goki.
What?
Was that typo on purpose? Those periods are after the 2. Or in front of the 2.
It's just,
No, that's on purpose.
it makes it a smaller, like,
Yeah. So that it's an abbreviation
Yeah, it's
abbreviation of inches. So they
Gotcha.
put a dot. And then it's the end of the sentence after the exponent.
Gotcha.
So it's weird. English is weird. I teach math.
like, you know how they put example, but they put EX in it?
Yeah, yeah.
Or
This is
EXC.
like getting rid of the one over
Or
front.
so
EXT?
divided
And
CCT.
then once that's
Etc.
done, we'll times by 5.
1.5. Or M. Or FT.
Yeah.
And miles,
Sure, they can really count. I'm just doing my KD.
All right, let's get this one going. What?
Oh, I knew it was gonna do
That's
that.
the next one.
I knew you were gonna do that. Yeah, I totally knew. Take it.
No.
Take it.
96 times 3 squared divided by 4 squared.
Wait.
Yeah.
Yeah, that matters.
Just enough arm reach.
All right, let's see. Pick something random. Ryan, set up the proportion for us, please.
3 squared over 4 squared equals x over 96.
All right, and then after we set it up, what did you get, Kylie?
I thought that was
Your
hilarious.
final answer.
Oh, wait, yes, perimeter is not the one.
Completely different answer than I did.
She was wrong the first time.
54 squared.
Yep.
So I did it wrong. I did it wrong.
No, it's 54.
No, I did it wrong. I used her answer.
Oh.
I got
54 inches.
176 inches squared.
All right, that's it.
Can that be
Not
our
bad.
ticket?
Well, whoa.
All right, so I don't know why these didn't print for you, so it's fine. Actually,
Fourth grade.
all right, you guys can be your extra ticket. So it's not on your paper because I printed it wrong. So look up on the board here, answer these 2 questions. I'll turn on Socrative, and then I'll put your homework on.
Oh!
You okay there, Chloe? You still alive?
That hurts so bad. I just heard going.
Okay.
Oh!